Well, hello folks. Today we're going to be talking a little bit about optimized placement for winter-morph spotted-winged Drosophila monitoring traps. This work was conducted largely by Ariana Hernandez in collaboration with Joanne Wong and myself, Matthew Grisham. We're all part of the Department of Entomology at Michigan State University. Spotted-winged Drosophila, or Drosophila suzukii, is a vinegar fly that originated in Asia. Unlike the native vinegar flies we already have in the United States, it has this specialized ovipositor which allows it to penetrate ripening fruit. What this means is this fly can attack fruit before it's already been compromised by rotting or a split or something like that. The vinegar flies that we've had in the United States all require that state before they can lay eggs in fruit and take advantage of it. In addition to its bladed ovipositor, spotted-winged Drosophila, like most vinegar flies, has a very rapid life cycle. This insect can cycle in as short as a week from egg to adult. And adults can live for 20 or 30 days. So what this means is that very quickly you can have overlapping generations, which results in a very difficult pest management situation. Another interesting aspect of spotted-winged Drosophila is that it has a dimorphism, or a different morph, that we think is important to its overwintering success. This winter-morph is a darker morph that is triggered by short day length and low temperatures. Both winter-morph and summer-morph can be caught in traps, although we typically catch far more summer-morph even in the late fall and winter months than we do winter-morph. Monitoring spotted-winged Drosophila adults is most often accomplished with drowning traps. The trap here is a typical one. It consists of a deli cup with a drowning solution, in this case made of a yeast sugar solution, and a sticky card. There are holes along the top of this trap to allow flies to get in, but to keep larger organisms out. Other traps use a commercial bait like this sentry bait. It still has to have a drowning solution though. We typically suggest that folks put traps near woodlots because it seems like population densities are highest at the fruit-woodlot interface. As mentioned previously, we rarely catch winter-morph flies in our monitoring traps. Even in the fall and winter, we much more frequently catch summer-morph, but we know they're active in the environment. So there have been a variety of ideas to explain this. One is that maybe there are just very low population densities of winter-morph flies, and this is possible, hard to test. Another hypothesis is that it could be the wrong lure. Maybe we're attracting them to the traps with the wrong thing. This has been looked into and is not the case based on laboratory work. Another idea is maybe we're putting the trap in the wrong place, and that's a big part of the study that I'm showing you. And then finally, maybe we're using the wrong trap. Ariana Hernandez, the master's student who did the work that I'm presenting today, asked questions about whether winter-morph flies had a differential response to low traps versus high traps compared to summer-morph flies. She did this in cage studies in the laboratory. These were replicated 5 times, and she hung a cup trap, put a cup trap on the floor, and put 120 summer and 120 winter-morph flies per cage. She then went back in 24 hours and observed her recapture rate. And basically, this is what she found. So this figure shows you summer-morph recaptures in the lab in black and winter-morph in purple. The cup trap on the floor is here, the cup trap hanging is here, and this is the adjusted proportion recapture of these two flies. What I mean by that is if we found dead flies in our release apparatus, we subtracted those from the total number so we could get an accurate count of who actually responded to traps. And so the pattern that really comes out from this is that summer-morph is caught in both conditions, although more in the cup. But winter-morph, we largely only caught on the cup and the floor. We didn't catch many winter-morph in the hanging traps. So lab studies are great, but they're very controlled, and sometimes organisms will behave very differently in the field. So Ariana followed up her lab work with a field trial. She did this at 6 MSU woodlots, and she established 4 trapping treatments here, and this is actually an ongoing study. We're still using this study design. Her 4 treatments included a cup hanging trap, a cup on the ground that was put under a hardware cloth to keep the raccoons out, and then she looked at a different trap design, one that we felt would be more suitable for use on the ground. This is a store guard trap, and she looked at it placed on top of the ground, and then because of the design of this trap, she was able to put it under leaf litter and look at it there as well. So a little bit on the store guard trap. This trap was designed for stored product beetles and for monitoring in flour mills and retail stores. It's basically a modified pitfall trap. There's this volcano-like dome that has the pitfall, and then a dome covering which can keep dust and liquids and things out of the trap. The way it works is the insect walks up this ramp and falls into a drowning solution. We modified our traps so that they had an equivalent amount of drowning solution as our cup traps. I'm going to show you data collected beginning in October of 2019 through May of 2020, and then the continuation data from May to September of 2021. There are 2 figures to show you this data. The top one shows you recapture or capture over time. The lower shows you the total capture over that time. Spotted-winged Drosophila captures in hanging cups are presented in solid black squares, cups on the ground in open black squares, dome ground in closed red circles, and dome under the leaf litter in open circles. If we look at this, basically what comes out is that during this short period in November and December, we caught more spotted-winged Drosophila on the cup on the ground compared to the other locations. However, we didn't catch a lot of flies. The max scale on this is 3 flies per day. This shows the total capture over time, and it also shows the non-target flies caught in these 4 trapping conditions. No significant differences were detected for spotted-winged Drosophila based on mean flies caught. However, we did see significant differences for the non-spotted-winged Drosophila drosophilids. Basically, they were caught in the cup on the ground and the cup hanging more frequently than the dome traps. So while we couldn't make any conclusions based on mean trap capture, we can say something about how good these traps are. To do this, we looked at the data a little bit differently. Basically, what we did was we asked the question for any spatial trapping location in any trapping time period where we caught at least 1 spotted-winged Drosophila, which of these traps caught the most spotted-winged Drosophila? So the cream bars provide you the number of times a particular trapping condition was the #1 trap, and the blue is when it wasn't the #1 trap. And a pretty clear pattern emerges from this. The cup on the ground caught the most spotted-winged Drosophila far more frequently than the other 4 trapping conditions. So based on this, we can conclude that this is likely a better trapping condition. Let's talk about the second half of this data. So this data shows from May 1st, 2020 through September 26th of 2020. So basically from the spring through this early fall. We're still keeping this experiment going. We're still just processing data. Figures are set up just the same as the previous slide. And what we really noticed from this is that first and foremost, we see the dome ground and dome leaf litter traps suddenly become very competitive during late August through early September. And this was very surprising to us based on the performance of these traps earlier. If you look at the overall trap capture, so over this entire time, again, for spotted-winged Drosophila, we don't see any particular trapping condition providing a more competitive trap result. But again, for non-target Drosophila, there was definitely a preference. In this case, we saw non-target Drosophila primarily in the hanging cup trap. So what's the take-home message? Well, based on our laboratory work and our continuing field work, we feel that when monitoring spotted-winged Drosophila beginning in the early fall through the winter, if you're going to do this outside your plantings, you should consider putting traps on the ground. It seems to be that spotted-winged Drosophila, both winter-morph and summer-morph in that period, show up on the ground a bit more than they do in hanging traps. We were really surprised by how well our dome traps performed, especially the one under the leaf litter during the late August, early September period. And this has got us thinking that perhaps we're seeing an indication of where spotted-winged Drosophila wants to go for the overwintering period. This is important because if this is indeed the case, maybe we can start to identify management protocols to limit their overwintering success, which would limit theoretically the inoculum that invades our crops in the following year. So next steps for this project, we are already evaluating early and late season spotted-winged Drosophila trapping locations in sweet and tart cherry orchards at the MSU campus, and we'll be presenting data on that probably in the next year. We are also thinking about ways that we can incorporate this ground trapping into helping us make phenological model predictions of when spotted-winged Drosophila is first going to become a problem. And obviously this is of critical importance to our early fruit crops like cherries. And then finally, this has really got us thinking about ways to identify whether or not leaf litter is an important spotted-winged Drosophila overwintering resource. And a lot of people help with this research. So I'd like to thank Allison Fisher, Keith Kunter, Kyle Ackred, Bracinda Hernandez, and Alex Yerlob for either helping with rearing flies or counting the thousands of flies and other insects that came in from our trapping study. This research was funded generously by Michigan Cherries and Project Green at Michigan State University. And once this video ends, I will answer questions. If you're watching a static presentation of this, feel free to ask a question in the comments and I will try to get to it.